As we've already seen in the pointer lecture, we can utilize pointers to allocate memory for new variables. We can also allocate space to create an array. Because we're allocating space at runtime, we no longer need to know the exact size of the array at compile time. So up until now we've been using static arrays. For static arrays, we must know the size of the array at compile time, and we can't resize it. With dynamic arrays, it can be set to any size, and we can then later on delete it and then recreate it in order to resize it. Even though it is more work to deal with dynamic arrays, not being tied to a maximum value in your program can be pretty powerful. So, with creating dynamic arrays, step 1, create a pointer variable. Step 2, make a new array with this pointer. Step 3, we use the array like normal. And step 4, never forget to delete the array when you're done with it. Step 5, good job. Resizing a dynamic array isn't as simple as adding on to the end of it, unfortunately. But we'll write data structures later, so more on this in the future topic. In order to resize an array, we essentially have to make a new, bigger array, copy the contents over, delete the old small array, and then change the pointer to point to the new array. So, let's say we've already created an array, but it filled up quickly. Now we need more space. We will need to create a new array with more space, and we need to copy the values from the smaller array into the larger array. Now, we don't need the small array anymore, so we free that memory with the delete keyword. But we still want to keep using the variable name names. We don't want to use the variable name new array, that's ugly. So no problem, it's a pointer. We just change where names is pointing to the bigger array. And then for new array, we set that to null so we don't misuse it later. Now we can keep reusing our names array. But also don't forget to free the space at the end of the program. What is the point of programming? Essentially, it's to automate tasks so we don't have to do them. This is why I prefer computer games to board games. Roll my own dice? Keep track of my own stats? That's a computer's job! So, if we don't want to keep track of new and delete, and we don't want to keep rewriting resize logic every time we need a bigger array, why not wrap it all in a class? Through the magic of classes, you can put everything you need to deal with dynamic arrays in one class. So let's work with some dynamic arrays to get a feel for them. And let's write a special wrapper class to show how we can use classes, their constructors and destructors, to handle a lot of the dynamic functionality for us. Here's a sample program that is using a static array right now. It just asks for a series of prices and then we can enter it. It'll give us the sum. It's a static array, so it's stuck at the size of 3. We can't really change that at all. So let's say we want to use a dynamic array instead. And let's have the user choose the size. So we'll create a size variable, size of array, input size. We're going to hope that they don't input like a -1, because I don't even know what's going to happen if you try to allocate that size. Yeah, it's negative, doesn't let you do that. Okay, so this is a static array. We don't want that anymore. We're going to create a pointer for prices, and we can either initialize it right here to some size. We can hard code it, or we can use a variable. We can basically initialize it as soon as we declare it, or we can do it on a different line. So float prices, prices equals new float of some size. So whichever you prefer. Okay, so now that we've used the new keyword, you should get into the habit of immediately adding your delete keyword. So since this is an array, we need delete followed by the square brackets and then the name of the variable. So free our memory. Well, what else do we need to do? Well, nothing. We might change this to size so we can iterate through the right amount, but otherwise that's all we need to do to change this static array into a dynamic array. I'm going to put this on the same line. We updated this, we updated that. We have a variable to dynamically choose what size of the array it is, and now we can choose whatever, 5. And there we go. Okay, now let's use dynamic arrays, but we'll resize it anyway. So we'll create an array of presidents, and it is a string, and we'll just start with 5. So we can set these names if we want. Name 0, George Washington, and blah 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 blah. Okay, so, well, we have more presidents and we've run out of room. So now what we have to do is create a new array. So we can call this, temporary array or something, just because this is going to be used to create the new array, but then we will get rid of this pointer later. So let's say, now let's just have 10. So next step is to copy everything over from the old array to the new array. So we know that there are 5 items in the old array. I'm going to say temp array I is equal to names I, and then we'll delete the array that names is currently pointing to. So delete names. Now, the pointer still exists. This doesn't delete the pointer. This deletes whatever it's pointing to. So we want to keep using the, oh wait, sorry, this is presidents, not names. We want to keep using the pointer name presidents. We don't want to use temp array. That's fine. We can basically just point the president's pointer to whatever temp array is currently pointing at. So remember, the values of these variables are just memory addresses. You can kind of assign them like other variables, but instead of assigning the value here, I mean, it is assigning the value. It's assigning the memory address. It's not assigning like George Washington or John Adams or something like that. Okay, so now our president's array pointer is pointing to this array. It was pointing to this one, but we've copied the values over and now it's pointing to this one. Okay, so now that we are doing that, let's say temp array, we're going to point that to null, because as it is like this, both of these pointers are pointing at the same array. And that's okay, that's not necessarily a bad thing. You will want to keep track of that, because that can lead to programming errors if you try to delete both of these. That's why I'm just setting this to null, so we know that it's done. We're not using temp array anymore. It's just kind of reset back to 0. Okay, so now that we've done that, we can keep using the president's array. But now we have 5, 6, 7, 8, and 9. So let's pretend everybody had a second term in that order, because I don't want to type everything back out again. And say I is less than 10, I plus plus. We could output, let's say I plus 1, so instead of 0, 1, 2, 3, it'll be 1, 2, 3, 4. And we'll output the name. And again, I put names instead of presidents. Sorry. Okay. So that'll display all the names of those, and then we can make sure to delete the new array again. So we've had a total of 2 news and only 1 delete. So we need to make sure to delete the other thing. This was deleted at this point, and then the array of size 10 will be deleted at the very end. So let's run it. I have an error because I named this names. Run it again, and there we go. Now let's write a class that will wrap all of our dynamic array stuff. So at the moment we're going to make this a dynamic string. In the future we'll learn how to make it generic so we can put anything, any data type in here. But for now, we don't know how to do that. Or at least I know how to do that, but you might not. So we'll just stick to strings. Okay, so we'll create a class. We'll name it dynamic string. And behind the scenes, it will have a string pointer. So we'll call this string list. And we'll want to keep track of the maximum value. Okay. Let me move this over here. So we'll have a constructor, and we'll take in a size. So the constructor will handle calling the new keyword to create the dynamic array. Then we'll also have a destructor, and it will handle destroying or freeing that memory. So for example, let's go ahead and make those over here. So they'll pass in a size. We'll set the max val to that size. Let's see, I forgot to put this in here. So they cannot create a dynamic string without giving it a size. Then we will say mStringList is equal to a new string of that size. And in the destructor, we're going to delete it. Now, we don't have to worry about allocating and deallocating the memory as much. If something goes wrong in the program and there's a crash, there could be a problem, but at the moment we're not worrying about that. We'll just assume at some point we'll declare a dynamic string, and it will eventually hit the end of the program. We're going to assume nothing is going to go wrong. Okay, so if we wanted to declare it, we could do it this way, but we would need to pass in some size. So that'll run. Okay, but this doesn't have much. All it does is allocate the data. We can't actually store anything in here at the moment, so let's create some more variables. We'll create an add function, and we'll say that they can add something at a specific index, just like an array, and whatever the value that they're going to store. Or we could also get a value, and we'll let them pass in the index of the value they want, and it'll return a string. Let's also have a size function that will return whatever this value is. So we can implement these over here. That'll return the size for us automatically. And void add at some index and some value, and get at some index. So the string has been created up here. We could just say return at this index. Now we might want to add some error checking. If they have an index that is out of bounds, that could cause a problem. So let's say if index is less than 0, or index is greater than or equal to the max value, then we'll just say this is incorrect, we can't do this. We can use CERR, like cout, to display an error message. Error, invalid index. And then we'll return just an empty string. But if it's a valid index, we can return the item at that index. So that'll build. We're not adding anything at the moment. So if we want to add something to the list, simply we could do mStringList at that index is equal to the value. But again, we should check to see if the index is valid so we don't go outside of the array. So if index is less than 0, we'll say error invalid index. But what if they give us a size or an index that is greater than our maximum value? So if index is greater than max val or equal to, we might want to resize it at this point. So we'll implement this later. we're going to return here. You can return from a void, you're just not returning a value. We are returning, so it's not going to assign that value. Okay. So that's quite a bit of functionality. Let's go back to main, and we can just set some values. Muffins.set 0 chocolate. So instead of having an array like this, we've wrapped it inside of a function, inside of a class. There is a way we could use this class and write it this way, but again, that's a topic for later. For now, if we want to use this dynamic array, we have to set values. We have to add values and get the values with the get function. So we can add a few of these. 1, 2, 3, 4. And we can also do a nice for loop to output everything. I is less than muffins.size, I++. We can output I plus 1 and muffins.get at this index, and it will display a nice list for us. There we go. So what if we want to add the ability to resize this array? Let's go ahead and say we're adding 5 and 6. We'll make this, I don't know what other type of muffin flavors there are. Chocolate chip, maybe? So when we run this, this isn't going to work. This is going to cause a problem because right now we're not doing anything if it's going outside of the array. It can cause a problem. It'll give us a segmentation fault. So let's implement a resize function. Alright, so a resize function. Well, I'm going to make it private because the user doesn't need to worry about the actual functionality behind resizing. To them, they're just adding stuff to the list. They don't need to know when it's resizing or anything like that. It's all magic and they don't need to worry about it. That's basically the idea. So we'll have a resize function and we'll pass in a new size to resize it to. We'll call it up here, and whenever they're using some index out of range, let's make it index plus 10 just to give it a little bit more wiggle room. That way we don't have to resize it every time they add something new to the list. So down here we'll just do our resize the same way as before. We need a temporary array, so temp array is equal to new string of the new size. We need to copy everything over from the old array into the new array. So temp array I is equal to our string list at I. Now we need to delete the old small array. So delete in string list I. Now this pointer, it still exists. We've only deleted what it's pointing to. So we can keep using this, oh, sorry, not there. We can keep using the pointer, and we want to keep using the pointer because it's the member of the class, and that's what we're doing all of our data manipulation stuff on. So we'll reset the pointer to point to the new array, and we'll set this temp array to null just because it's good practice to do so, and we'll change the max value to the new size. Okay, so we have one new here and one delete here. We're not deleting anything else because, again, the destructor will end up clearing that memory once the dynamic string object goes out of scope. So back in main, we're adding multiple things, and it will let us show a size afterwards. Let me go ahead and run it. And there we go. So it got to number 6. It was like, we don't have enough space for that. We're going to make it a size of 16. So now we have 16 slots or 16 elements. And that's good. We have some wiggle room to keep adding stuff, and we don't have to resize every time. So we have 7 things now, and that's good. So that's how you would write a simple wrapper to contain a dynamic array. We need the resize functionality, and we'll have get add and as well as allocate and deallocate our memory.